Let's get started. If you guys would, again, close up your lids, put away your phones. Actually, you have plenty of time to click on these answers, guys. I'm going to be up here for maybe 10 minutes, okay?
That's what they all say.
Oh, and also, real quick. Okay, so we're on number 11. And they give us some data, and they ask us if it's exponential or not, okay? So they give us a table of values, x, y, and the x values they give us are 1, 2, 3, 4. 1, 2, 3, 4, and the y values they give us are -2, 0, 2, and 4, okay? They're asking us if this is exponential or not. Actually, it's exponential or is it linear, okay? So what you need to look at is this, okay? I mean, the x values, they're 1, 2, 3, 4. They're increasing by 1. What's happening to the y values? Went from -2 to 0.
It's going down 2.
It's rising by 2.
It's going up by 2. How often is it going up by 2?
Every.
Like some of the time it's going up by 2?
No,
all the
every.
time.
All the time. It's going up by a constant rate. That means, remember, exponential is not constant. Remember with the checkerboard, it started off slow and then it just took off eventually. This is linear. If it has a constant rate of change, it's a line, okay? So this is linear. It's not a exponential function. This is linear, and the reason is you're clicking and dragging answers here. And then it says, as x increases by 1, what's happening to the y values again? We said it's doing what happens to y?
Rise increasing.
Rises, but it's going to be increases what they want you to put. But rising is fine. But you're going to click on increasing by how much?
2.
By 2. I think that's what we're going to. Oh, nope, not 2. That's not what we're going to. It's going to say increasing by 2. And then it says the rate of change, it is or is not constant?
It is.
It is. So these are what you're going to click on. Linear, increasing, is, okay? Filling in the blanks, okay? All right, let's look at number 13. Number 13. Okay, number 13 looks like this. Now they have your data, but it's horizontally instead of vertically. Still do it the same way, though.
Ooh, big shocker there.
Okay, 0, 1, 2, 3, or -1, 0, 1, 0, 1, 2, 3. Is that as far as it goes? Yep, and it goes 0.25, 1, 4. 0.25, 1, 4, 16, 64. So, when we're looking at these, the x values, again, they're changing by 1, -1 to 1, or -1 to 0, 0 to 1, 1 to 2, 2 to 3. And if you just look at this, I think it should be pretty, without doing a whole lot of calculating, just looking at the numbers, is it going up by the same amount every time?
No.
No. I mean, from here, from 25 cents to $1, that's 75 cents. From $1 to 4, it went up by 3. From 4, you may not be able to do this in your head, but you know the difference between 16 and 64? It ain't 3, it's a lot more than 3. It went up a little more, quite a bit more than a whole bunch more, okay? This is not linear, okay? This would be exponential.
Yeah, because it was just multiplying it by 3 and then it stopped at 64.
Not by 3. They're multiplying by something, okay? How do you go from 1 to 4? They're multiplying. Okay, you could be adding, but we're multiplying, okay? When it's constant, you're adding the same thing every time. Here you're not, you're timesing. How do you go from 1 to 4? You times 4. If you times this by 4, you get that. You know what 16 times 4 is? 64. They're multiplying by the same thing. Linear, you're adding the same thing every time. Exponentially, you're multiplying by the same thing every time, okay?
Yeah, but
So
if it's a 1, then that would just stay one and flat line of 1 across the whole thing.
no, because we're timesing by 4. We're timesing by 4.
Yeah, but like, oh, because you're timesing the 1.
Yeah, we times the 1 by 4 to get that. And what's 4 quarters?
$1.
$1. 1 times 4, 4 times 4. Always times by 4. Okay? And it is because as x increases by 1, y, again, is not adding, it's multiplying by 4. So it is or is not a constant rate of change?
It is.
It is a constant rate?
Oh, no, it is.
No, it's not. It is not a constant rate of change. It's going up a little, then a little more, then a bit more, then a whole bunch more, okay? Number 15. 3 more I'm going to do with you guys. Okay. Now, they're giving us an exponential function. And it says y equals 3 to the x. 3, and it's 3 to the x, not 3x. 3x means 3 times x. This is 3 to the x. They want you to evaluate it when x is 2. So all that simply means is you plug in 2. Why are we plugging 2 in? Why don't we plug
'Cause
5
it
in?
says so.
Because it says so. It says plug in 2. So y equals 3 to the power of 2. The most popular wrong answer is 6. It doesn't mean 3 times 2. It means 3 times itself. What if it was 3 to the 4th? Then it would be 3 times 3 times 3 times 3. Okay? So what is 3 squared? It's not 6. It's what? What? 9. 3 times itself. 3 times 3. So the answer is 9. Okay? It's an exponential function. You're just working with it. Okay? Let's look at number 17.
What?
I almost said 16.
17.
17.
I already
Okay.
skipped that 15.
Okay, negative 4, 5 to the x equals negative 4 times 5 to the x, and they're telling you to plug in x equals 2. They like the number 2 apparently. Now, we haven't talked about this yet. So we plug in 2, and again, Connor just answered this a minute ago. How do we know we're supposed to plug in 2? It tells you on the computer. The computer says plug in 2. Now, we've not talked about this yet. Do we multiply first, or do we do powers first, or doesn't it matter? It matters. I'm sorry, whoa. Don't multiply first. Don't multiply first. You do powers first, okay? 5 squared, it is not 10.
25.
Right, where'd you get 25 from?
5 times 5.
What if it was 5 to the 3rd? Then it would be 5
That's 5.
times 5 times 5, which is 125. That's how it is. So it's negative 4 times 25, and you can do this in your head. What's 4 times 25? What's 4 quarters?
$1.
So 100, but it's negative 4 times 25, so it's
Negative 100.
negative 100. You can use a calculator, but you don't need a calculator for that. Last one I'm going to do with you guys. Number 19. Again, they give us a function. 1/3, 6 to the x. Y equals 1/3 times 6 to the x power. This time they want you to plug in, where are we at? 3. This time x equals 3. So we plug in 3. So we have 1/3, 6 to the 3rd power. Again, you do powers first. 6 to the 3rd does not mean 6 times 3. It means 6 times 6 times 6. Okay? 6 times 6 is 36. And you can use calculator. I don't expect you to know 36 times 6 in your head, but you can use a calculator. It's 216. Okay? Parentheses mean multiply, okay? So 1/3 times 216. I'm going to make 216 a fraction. 216 over, how do you make anything a fraction?
Over 1.
Over 1. Times your tops, times your bottoms. 1 times 216 is 216. That looks terrible. 216 over 3 times 1. 3. I think I taught you guys the rule for 3. Does 3 go into 216?
No.
Wait,
You guys remember the rule for 3? I'm sure I taught you guys this one.
Nope.
it's not.
I don't think
it's
you
not
have.
even.
Does 3 go into 501?
No.
If I taught it to you and you remember it, you should know it almost immediately.
No.
3 definitely goes into that. You guys remember the rule for 3?
No, I don't think you've told us.
Maybe I didn't. Okay. Like there's certain rules you know. Like for example, what's the rule for 2? 2 goes into what numbers?
Even.
Even. What's the rule for 5? Not necessarily odds.
Odd numbers.
Not necessarily. 5 goes into 20. 20's
Oh,
not
wait.
bad.
Negative numbers.
5 goes into numbers that. Does 5 go into 714?
No,
Why?
because it's not even.
Yeah,
It's
it
not
is.
odd. It's not odd.
It's not a factor.
You guys don't remember the rule for 5?
But it's the
Well, how can I?
Give me the numbers that 5 goes into. 5, 10,
And
Oh, does it end in a 5 or a 0?
5 or 0. You guys remember that, don't you?
No.
5 goes into numbers that end in 5 or 0. Okay. The rule for what's the rule for 10?
It's gotta end in a
Ends in a 0. Ends in a 0. Okay. The rule for 3, and I know they teach it now at least because my daughter's in 8th grade and she learned it last year I think in 7th grade. Maybe they didn't teach it back when you were there, or maybe you just forgot it. It's real simple. Add up your digits. What's 5 plus 0 plus 1? 6. Does 3 go into 6?
yeah.
So 3 goes into that. You know how many times? I don't know, but it does. Okay? Does 3 go into 417?
Yeah.
Why?
No.
I don't know, it's an odd.
That's not what I just said. What did I do with these digits?
Add it.
Add the digits up. What's 4 plus 1 plus 7? Does 3 go into 12? So 3 goes into that. How many times? I don't know, but it goes into it. Does 3 go into 500,004?
No.
Yeah, why?
Because 3 goes into 9.
Where'd you get 9 from?
5.
5 plus 0 plus 0 plus 0. You don't have to add zeros. Okay. 5 plus 4. Now, how many times does 3 go into that? I don't know. Does 3 go into 216?
Yeah.
Yes.
Why?
Because 2
'Cause
plus
it's-
1 plus 6 is 9.
And 3 goes into 9. Okay? One
That's
more, just want to make sure.
genius.
Does 3 go into 4,714?
Yes.
Why?
Wait, no.
Why? What are you guys doing?
It wouldn't go in.
What are you guys doing?
Thinking.
No, what are you supposed to be doing with those numbers?
Adding them.
What's 4 plus 7 plus 1 plus 4? 16. Does 3 go into 16? So 3 don't go into that. Okay? So 3 does go into 216. You can do this in your head. How many times does 3 go into 21? 3 times what gives you 21? 7. 3 goes into 6? 2 times. 72. Okay? So you learned something new today. What 3 goes into. It ends in, or if you add them up and 3 goes into it. Okay, so what you need to do is this. You don't need to finish the assignment. We're almost done with this assignment. We're going to finish it up on Monday. I'd like you to finish up through 20, okay, through number 20. Okay, so click on the ones and fill in the ones that we skipped over. All right? The rest of the time is yours to work on it.